So, welcome to MA 465, not I guess, industrial machine mission. So, yeah. So the area that we'll be talking about today is morphological transformations or morphological processing. So these are not my slides. I'm using Dr. Rangarobligo's slides from for this particular task, for this particular section. So it's not my slide. So the slide credit is supposed for him. So I think I don't think we have to go through the theory once again, but basically it's like once you set up like you do some sort of like an operation to this image. So once you do some sort of like this thresholding operation to these images, there can be certain sort of like discontinuities and maybe added pixels, right? So which you don't want the image to have. Say like you say you want like a proper segmentation done, but there can be sort of like some discontinuities which have happened because of thresholding parameters. Say imagine there's a image like take something like this, right? Say give me a second, writing pad. So imagine a scenario like this where you have this ring-like structure in an image, and you threshold this and say so there's a shade here, right? Say there's a shade here. So you want to segment out this ring, right? But due to some lighting issues, there's a shade here, right? But when you convert this into like a digital image, you will have a certain level set of pixels, and say you're going to do some absolute thresholding, and you're going to threshold uh, 128 as the thresholding parameter, and all the pixels with the intensity level of 128 and above will be thresholded to 255, and the ones below will be thresholded to 0, right? So it will be, we'll get a binary image, zeros and ones. So say imagine this, you want to segment of this ring, but due to some reason uh, there's a shade over here, and because of the shade you can't there's a discontinuity, right? So මෙම මුද්දක් වගේ එකක් තියෙනවා. ඔයාලට මේක segment out කරගන්න ඕනේ. ඔයා thresholding operation එකක් කරනවා මේ මුද්දට. හැබැයි ඒ threshold එකදී ඔයා absolute thresholding කරනවා. මේ range එක මේ range එකෙන් උඩ pixels සුදු කරනවා. ඊටු ටික black කරනවා. මේ shade එක හින්දා මේ range එකේ තියෙන pixels ටික මේ හිතන්නකෝ මේ 128 range එකෙන් පල්ලෙහා දෙන්න කියලා. So then once you threshold this, you will get an image of this sort, right? So yeah. So in a case like that, if you want to say like segment out this properly, there are certain set of like operations that you have to do to this particular image to get this segmented output, right? So what you can use these morphological operations, right? And get this done, right? So so basically we can say that this is actually an operation that is very useful after we binarize the image. Binarize means like so basically it's useful once we can say it's useful after binarizing the image, right? Binarizing means basically after we perform a thresholding operation, okay? Because after you threshold the image, you get a binary image with ones and zeros, right? So also at the same time, now this I was talking about these discontinuities, right? So we can basically combine these discontinuities and get a proper image. At the same time, imagine the same scenario. Now you want to segment out this image, right? You want to segment out this image, but at the same time, once you segment this out, there can be certain other noises, right? Say like salt noises, white noises, right? So you at the same time you probably this remember morphological processing. Generally, we always talk about images after doing the thresholding operation, after binarizing. That is very important, right? So if you are asked in a theory question, say you are asked in a theory question, you want to say you are asked to like say segment out a particular, say in the same case, we'll take the same scenario. You want to segment out a ring from the background, right? So in a case like that, remember, uh, you have to and you're asked what the steps are, right? You want to say there's a table, and you say there's a conveyor, right? So we'll take that. There's a conveyor, and there's a say set of rings going on that conveyor, and you are mounting a camera on that conveyor, and you are trying to count the number of rings passing by the camera. So in that case, you have to segment out the ring out of the conveyor, right? So in a case like that, so if you ask the sequence of operation, you always have to do the morphological processing if you are to do that, right? It's not compulsory that you have to do the morphological processing. Morphological processing means basically opening, closing, dilation, erosion, right? We'll talk about them separately. But if you want to do this morphological processing, please note that generally it's not an absolute thing, but generally it's done after the binarizing, right? After the image is threshold. Okay, keep that in mind. So that's about that. So now, if you take these operations, these morphological operations, there's mainly 4 operations. There's 2 basic operations, right? That's erosion and dilation. These are the 2 most basic operations of morphological processing, right? As a combination of this, we can have other operations like opening and closing, morphological gradient, top hat, black hat. All these things are there, but our main focus is going to be on erosion, dilation, which are the 2 basic operations. At the same time, what opening and closing are, right? For the time being, you don't have to worry about this morphological gradient and all these things. But I think we did a little bit of this in feature extraction about gradient. At the same time, you all probably might have come across the hysteresis thresholding, right? I did hysteresis thresholding. I think you can watch the video if you can't remember. Under feature extraction, where you actually have like discontinuities, you can use hysteresis thresholding to combine these discontinuities, right? This is what I mentioned. Like, so you will sometimes, if there's discontinuities of an image like this, say image discontinuities like this, there are 2 ways that you can use to combine them. This is like an example, the image that I'm taking. So one is morphological operations. That is, in this case, it will be mostly dilation, which you use to combine. At the same time, you can use something like hysteresis thresholding when you're thresholding. So if you ask the difference, note that hysteresis thresholding is applied to grayscale image, right? It's like a normal grayscale image that you're applying thresholding. But morphological operations you're applying for already binarized image, right? So know the difference, right? Thresholding operations, whether it's absolute, hysteresis, adaptive, whatever thresholding method that you're using that to you're using that on a like a grayscale image, which has like intensity levels from 0 to 255 if you're using 8 bits. So, but if you take this thing, if you take morphological operations, you're using that on a binarized image, right? So know the difference. Don't mix up the 2, right? So that's about the basic operations. I don't want to spend a lot on theory. We'll do some, because examples are the best way to understand this, right? I will try to do some coding as well, so it's so we can see, like, because there are morphological operations are very simple code wise. There are already inbuilt functions in OpenCV that you can use to do this. Okay. Yeah. So mainly, as we discussed, there are 2 basic operations, morphological operations. That's dilation and erosion, right? So dilation basically, as I said, so we use when there are like discontinuities, we use that to combine the discontinuities. It's like an operation that grows or thickens objects of a binary image, right? Say there's so we'll discuss this. I don't want to draw and explain now, because we'll do an example, then you'll understand. But basically, what happens is if there are certain discontinuities like this, it's a sort of like combines them, right? So you know what dilation means, like in English, right? So that's what like when when light is sort of like related to your eye, your eyes get dilated, something like that. So eyes become like your eyeballs, like or the eyeballs, the what do you call those? The retina becomes enlarged, right? That's what we call dilation. Erosion is somewhat like when I can erosion, right? So basically, in erosion, what you do is there can be like this these are type of noises. So you can like filter out these noises uh, using erosion. Once again, if you asked a question, a theory question, okay, there's an image, it has these pepper noises, or maybe salt, not pepper, salt noises, uh, and you probably might be given an image, right? You are given an image and said, okay, there are salt noises, white dots, impulsive noises. How will you remove the noises? What do you think is the best way? So you asked a question. You are given an image which has white noises. So you are used to select the method to eliminate the noises. Hands up those who think erosion would be a good option. Is there anyone who think erosion would be a good option? Tell me someone who has an alternative option without erosion. So you all know. I think we discussed this. I'm not sure that we discussed it, but I think yeah. So you all probably might know that we use a median filter, right? For scenarios where we have this you know uh, impulsive noises, salt and pepper type of noises, right? So erosion can be an option and cannot be an option, because why? I told you that we are applying this filter. We are applying this to a already grayscale image, not a digital. Sorry, not a binarized image, right? So if it was a binarized image after the thresholding process, then we can go with erosion, because once the binarizing is done, these noises can be somewhat eliminated. You see, like say, even though we see them as white noises, this can be, say, imagine there's a person, right? There's a person's face. So his hair is like this, right? So say imagine his hair is black, and these white noises can be here, right? So now once you binarize, so because of this contrast, right? Because of the black and white contrast, light and dark contrast over here, you can see this. You probably might be seeing these noises. But once you threshold, sometimes these noises might be eliminated. So in a case like that, you probably might not need to use erosion. I mean, we don't have to use multiple operations without any requirement, right? There's no like hard and fast rule that you have to always go with these morphological operations, because we want to have our codes to be very compact and very efficient. We don't want to have a set of operations without any purpose, right? So yeah, so you first go with something like a median filter, and then if it doesn't work, only we just do the thresholding, and then after doing the thresholding, we can say, okay, we can do the erosion operation to shrink them out. Okay, so I'm just talking about the practical aspects of this. So yeah, so yeah, we can see this is an example. So this is an original image of 30 by 40 pixels, and you can see dilated image. It has been thickened, right? You can see that these discontinuities, not that this is a discontinuity, but according to this image, somewhat like a discontinuity. So these have been joined. See, these have been joined, and so you can see this has been eroded, right? So yeah. So best thing to figure this out is through an example, right? So we'll do a small example and see how this is done. So so as if you remember, small thing I want to show. So you see in the morphological operations, right? So we can see here now they say something called a structuring element, right? See, structuring element. So in a morphological operation, it's like a you see it's like a it's like this there is like an operation where you give two inputs. The input binary image. Know this, right? Always keep this in mind. This is one thing that many people get wrong. It's a binary image, right? It's a binary image, and at the same time, you're giving a structuring element, right? This structuring element is somewhat like the kernel that we are talking about. So it's like a kernel. Here too, it's what we are doing is somewhat like a convolution operation, but a bit different. We are having the kernel is somewhat like the structuring element, and we have the binary image, and we sort of overlap the structuring element on the binary image and try to do the operation that we want. So I will show you how this is done with an example. So we'll go to the whiteboard. So yes, now I'm going to take an image. Say this is going to be the hard part, drawing this and getting it done. It would have been easy if we use some sort of grid, no? Like without using this, I will take some table sort of thing. So I will share this spreadsheet, right? I think this is easier. We don't have to draw all this. This should be to scale, right? But for the time being, we'll just take a small part like this and have a grid, right? We'll take this is our screen, right? Okay. So we'll consider an image, right? We'll consider this is our image, okay? So we'll see, we'll assume, say, this is our image. I'll just cut them out like this. Okay, this is like our image, okay? So think of it like that, right? Now first we'll do what we call the dilation, okay? Dilation operation. Or we'll do, yeah, we'll do dilation, okay? So these are all ones. I will mark ones if no, it's best easier. I'll mark ones. By the way, today also I'm using this, my Zoom account, so I didn't get a Zoom this thing, so we'll have to join maybe after 40 minutes. Okay, sorry about that. These are all zeros. Okay, so now we are asked to perform like say this is all are zeros, right? You get the idea? So we are we are asked to use this particular structuring element. The structuring element can be multiple types, right? We are asked to use this particular structuring element to perform the, say, dilation operation, right? Dilation operation, right? So now uh, you see, so always you go by the definition, right? If you're asked to do something like this, always go by the definition. What's the definition? What's the definition we have been asked here? What's the definition? Definition is the output image is one, the output image is one at each location of the origin of the structuring element if the structuring element overlaps at least one valued pixel in the input image. Right? This is the definition. This is all that you have to think about, right? This part. This is the whole idea that you have to think about. It's not very complicated. If this particular condition is met, that's it, right? If this particular condition is met, that's all we have to think about. Okay. So we'll see if that condition is met here in our cell. So now, so okay. And also remember, I'm not sure so were you all asked to flip the structuring element? So note that in these operations, the structuring element needs to be always flipped, right? It's a definition in OpenCV. Don't worry about that. So if the structuring element is like this, you don't directly go and plug this. You flip this particular structuring element, uh, as in like you reflect it, right? So and you reflect the structuring element around the, what do you call this, uh, around the origin. We call this the origin. This part is the origin, right? This is the origin. We have to flip the structuring element around the origin, right? So what we have to do is we have to say mark something like this around the origin and flip it around. So how do you flip it around? First you flip this around this and this. So what will you get? You will get, this one will be, anyway, we are going to flip this around this axis. So around the origin. So we will get the origin here. Once we flip this like this, we'll get this on top and this here. So even though we use this structuring element, the actual structuring element that will be applied on the image is this. Always keep this in mind. So if your structuring element is symmetrical, right? If your structuring element is symmetrical like this, say it's a 3x3 uh, with origin in this. In this case, of course, the fact that you flip this is not going to affect much, right? It's not going to be a huge problem. But in this case, if you're having this unorthodox eccentric type of kernel, not kernel, basically a structuring element, you have, once you make sure that you flip this. If you go and do the operation, morphological operation using this particular structuring element, is going to be wrong, right? So make sure to keep that in mind in your exams to flip the structuring element around the origin. Okay. So yeah. So now we have flipped that. Now we'll apply the structuring element on top of this image. Now, so I will try to draw the structuring element in one pen stroke like this and try to maybe use a different color. So I will use blue color here. So this is the origin, right? Structuring element. This is the now always remember this is the structuring element that's given. Okay. Say if you are given a question, you will be given this image and this structuring element, and you have to make sure to flip the structuring element around the origin, right? So this is the flipped one. When you're applying the structuring element to the image, you should use the fixed. Sorry, the flipped structuring element. Is it clear? So now we'll be moving the structuring element around, right? Okay. So what's the definition? The definition says the definition said that at least uh, if at least if at least yeah. So this is dilation, no? So if the origin of the structuring element overlaps at least one one value pixel of the input image, then we color the entire structuring element, right? That's the whole idea, right? I hope that is clear. So now we'll apply. So you will understand this when we are doing this. Okay, now we have the structuring element, flip structuring element. Original one is this. We flip it and we have it here. Now we are going to keep this on the image. Now we are going to keep it on this pixel. So sorry about this. So this content this sort of like you know extended ones. It should be like following this border, right? So when you keep it here, now you can see uh, the the this thing, the origin of structuring element, this picks this one, right? Is not overlapping any one value pixel, right? It's on 30 value pixels, right? So nothing happens, right? So we move it around here now. Now what happens? Okay, now here the origin of the structuring element is overlapping a one valued pixel, right? Now in this case, what we do is, okay, now the condition is met. Now what happens is all the you know pixels that's being overlapped by the structural element will be assigned one. So this will be one, this will be one, and this will be one. Okay, right. Now we once again move the structuring element here. Now what will happen? Now, of course, the origin is not overlapping a pixel that is one, right? So nothing happens. Okay, all here are zero. Nothing happens. We go back here, and now once we come here, right? Once we come here, you can see, okay, now here there is a pixel that that the structural element is overlapping, right? The origin of the structural element is overlapping. So what happens? So what happens is this becomes one, this becomes one. So we can go on like this, right? We can go on like this. We move it here. So already all everything is one. We move here. Now what happens? This becomes one. Anyone here also. This becomes one. Okay. So yeah, this is wait. I need to check on this. Hmm. we'll go back to the definition and see. Uh, okay, I made a small mistake, right? So yeah, I made a small mistake, so will correct that. So yeah, sorry, let's start. Yeah, I think I made a small mistake, right? So I'm sorry about that. So the definition says, so this is actually good for you guys as well that I made the mistake so that you all can answer this thing. So it says, uh, so what I did was I checked if the origin is overlapping with the image, and I color the entire structuring element. But what should happen is the opposite. If at least one value pixel, if the structuring element overlaps at least one value pixel, uh, the output image is of the origin of the structural element is made one, right? So that's what needs to happen, not what we did, right? What I did. So we have to correct that. So I'll do that. So now I have to draw this thing again, no? So I will draw that. In the meantime, I think the meeting will end. It will be ending in 5 minutes. So anyways, point of drawing, because then of course the meeting will end and I will draw again. So I will end the meeting now, and you can join using the same link.